Alright, welcome back to Chapter 5. We're actually going to finish Chapter 5 today with the substitution rule. Now, the idea of the substitution rule is that we are going to encounter some equations or some integrations of like this, alright? And if I ask you to find the integral of this, you couldn't, okay? It's nothing to do on you, it's just you don't know how, right? If this was the integral of just 2x or the integral of square root of x, or even 2x square root of x, you could still simplify that down. But because we have a binomial, we have a function inside of a function, so we have f, and I did that, I didn't mean to do that. Basically we have f g of x, okay, and then you would have times another function, so if h of x times this. We have like three separate functions here. The square root is a function, and 1 plus x squared is a function. So yeah, lots of functions here, and we have no way of finding the integral of this. So what we're going to do instead is we're going to use the substitution method. So I'm going to make a little, well, let's do Blackboard here, why not? So let's erase this. So the question is, we want to integrate 2x square root of 1 plus x squared dx. And again, there's no way to do this. So what we're going to do instead is we are going to say off to the side here, u is equal to 1 plus x squared. This is where the substitution comes in. Substitution. Okay, so we're going to say u is equal to 1 plus x squared, right? So that's going to give us square root of 2x square root of u dx. Now, again, if you know that this doesn't really mean anything except for we're doing the integration or the antiderivative of x. Do we want to do the antiderivative of x? And hopefully you're saying no, because we don't. We have u here. We want to do the antiderivative of u. So we need to find du. To do that, we are going to take the derivative of both sides. So we're going to do the derivative of both sides. So the derivative of this, according to u, so that's 1 du, okay, that just says 1 du, the derivative of this is 1 du. And the derivative of this, if you remember to the derivative, that cancels out, derivative of constant 0, bring down the 2, subtract 1, that's going to give you 2x dx. So what this says is I can replace 2x dx with 1 du, so another part of the substitution. And guess what we have? 2x dx. So integral of square root of u times 2x dx becomes the integral square root of u times 1 du. And I don't really need the 1 anymore. Okay, not important. That's all I have. Now I can easily do the integral of this if you change this to the integral of u to the 1/2 power du, which is, if you remember antiderivative, we're going to take u to the 1/2, we're going to add 1, which gives you 3 halves, and then we're going to divide by 3 halves. That's going to give you 2/3, because if you divide by 3 halves, you flip and multiply. So u to 3 halves, and don't forget to add the constant. All right. Now, this isn't the end result we want. The end result we want is what we asked for up here. We want the integral according to x. Now, this is the easy part. That's the hard part. We're really done with the hard part. All we do is we plug this back in for u. U gets replaced. So this becomes 2/3 1 plus x squared to the 3/2 power plus c. Now, just to show you that we're correct, again, in order to cancel out or undo the antiderivative, is we could take the derivative of this. Right? If you remember the derivative, we are going to, this is chain rule here, so the outside part is to bring down the 3 halves. Let's do this in a different color so we can see this. This is antiderivative. Let's do this in yellow. Don't show up well here. So, again, we're going to, nope, didn't mean to do that. All right, that's awful. if I can do this. There we go. So we're going to bring down 3 halves and multiply, which cancels that out. Subtract 1, which gives me 1/2. All right, that's the integral, and the derivative of the constant is going to cancel out. So that's the derivative of the outside. The derivative outside is 1 plus x squared to the 1/2 power. Then we multiply that times the derivative of the inside, which is 2x. So we get 2x, 1 plus x squared to the 1/2 power, or 2x square root of 1 plus x squared, which is what we started with. So yeah, this is the correct, right here, before all the markings, this was the correct antiderivative. That is the substitution method. That is what we're going to do every time. We are going to pick a function inside of another function, and we're going to substitute u in for that. We're going to do the derivative of both sides, and if we're lucky, something's going to cancel out. We're going to have everything we need to cancel out. We'll just have 1 du. Sometimes or not. For example, if this had just been an x here, I would have to divide both sides. So basically do 1/2 times both sides to get 1/2 du is equal to x dx. And then I'd replace this with 1/2 du. So I'd have to do some manipulation here, which is fine. You can do that. So let's clear this. Go back to the screen. So that's everything we got. Okay. So we're going to do, again, they even did the derivative so they can show it's true. All right. I'm going to ignore all this. Not really important. I just want to do practice questions. There we go. Practice questions. So let's do this in whatever color this thing is. So we don't want to do this, okay? So I'm going to take the function right here, this part right here, and I forgot to press the pen button. I'm going to take this function right here, there it is, and I'm going to say that u is equal to x to the 4th plus 2, all right? So that means if we do the derivative, okay, derivative, you don't have to write this out. Okay, do the derivative, both sides. We get 1 du is equal to 3, nope, not 3, bring down the 4 x cubed, and the 2 cancels, dx. Now, do I have a 4x cubed? I do not. What I have, though, is an x cubed. So, since I have x cubed and dx that I can replace, I have to get rid of the 4. So I'm going to multiply both sides by 1/4. So we get 1/4 du is equal to 1/4 times this, cancels out, just 1/4, x cubed dx. So now I have everything I need to get rid of the x cubed dx. So we integrate, and we have 1/4 cosine u du. Now, if you remember the rules about integration, we can just leave this outside the function. Any constant being multiplied through, we can just do 1/4 integral of cosine u du. Now, the integral of cosine, since the derivative of sine is cosine, the integral of cosine is sine. So 1/4 sine u plus c. Don't forget to add the constant, because this is an indefinite integral. You have to add the constant. Then all we do is we plug this back in for u. So 1/4 sine of x to the 4th plus 2 plus c. All right, not bad, not really. Okay, it's not too bad. I know it's me saying this, okay? So, but it's really not near as bad. As I told you, this class actually gets, what I like to say is easier as time progresses. Until we get to chapter 6, then it's a whole different story. So, just to make sure you're scared of it. All right, moving on. Let's clear this. And that's not clear. There's the button to clear it. So just to make sure we're right. There we go. There's the answer. Again, you could check if you want to do the derivative. I'm not going to. All right. Now, same concept. Those before were indefinite integrals. Now we're going to do some practice on definite integrals. Okay. So, same setup. Let's choose, I like playing with colors here. Let's do brown because that's a terrible color. All right. So we're going to say that u is equal to 2x plus 1. This is awful color. Sorry. I'm not really that sorry, and you know that. So du, do the derivative. 1 du is equal to 2 dx. That cancels, and that just goes away and becomes 2. We don't have a 2, do we, outside? So we get rid of that by multiplying by 1/2. So 1/2 du is equal to 1 dx. So now we integrate from 0 to 4 of 1/2 square root of du, which is, if I want to write, integral from 0 to 4 of 1/2 u to the 1/2 power du. The antiderivative of u to the 1/2, let's change colors as we do the antiderivative. Add pink back in here just to make it just even worse. Antiderivative means we're going to add 1, which gives me 3/2, and multiply by the reciprocal. Again, if we divide by 3/2, I'm multiplying by the reciprocal, 2/3. So that cancels, gives me 1/3 u to the 3/2. And I don't have to worry about adding the constant because this is f of x. Remember, capital F of x equals this. We have to find f of 4 and f of 0. A nice thing, f of 0 is 0, so I don't have to even stress that. Oh wait, no it's not. No it's not. No it's not, because I forgot to do one thing. Ha ha ha. Let's erase this. And if you caught me and what was my one thing I forgot to do, I'm not doing the derivative or antiderivative of u, I'm doing the antiderivative of x. So, which means once I do, I know that, come on, where's my pen? There you are. So capital F of u is 1/3 u to the 3/2. Then capital F of x would be 1/3 of 2x plus 1 to the 3/2. All right. So we have to do f of 4, which is 1/3 of 4 times 2 is 8 plus 1, 9 to the 3/2. And that is 1/3 of 27. That's 9. Okay. Because if you square root 9, you get 3. Cube 3, you get 27. And 1/3 of 27 is 9. All right. F of 0 is 1/3 of 0 plus 1. So 1 to the 3/2, which is 1/3. So we get 9 minus 1/3, which is 8 2/3, or 26/3, depending on how you like to write your answer. So, there we go. Now, downside is about doing all this again is I can't see people, so I can't look at people's face and realize I'm doing this too quickly. Hopefully, you've mastered the pause button so you can take notes and still keep up. And then again, you can watch this as many times as you want, because I know you just love hearing my voice. Sorry, I cracked away even when I said it. That was just perfect timing. So yeah, take your time with this. I know I'm moving quickly. It's because, again, it's 10 o'clock at night. I have to do these at night because I can't do these during the day with my kids awake. I've tried. I can sometimes do it, but yeah, I think if I may have done one with you guys in the background. You can always hear the kids coming up and talking and sometimes screaming and yelling and being 3, 5, and 7 year olds just not getting along with each other. So anyway, just pause, take notes, and then listen to it, and listen to it as many times as you need to. Okay. Moving on. Yep, 26 over 3. Done. Symmetry. Yeah, this will be important to have. If you have what's even symmetry, this will actually be on the test, or say on the test. I don't know if it'll be on the test. I don't know how I'm going to test you guys on these. So, you may just have a take-home test to do. Yay! Take-home test. Open notes. So, I mean, if I give you anything, I don't even know if we're even going to come back to school at this point. Because when we do go back to school, we have like 2 weeks left of school. Because we come back. It says till the 24th. It really means the 27th. Okay, because everything's close till the 24th of April. And you guys graduate in 1, 2, 3 weeks after we come back. So basically, you come back, we need to be taking finals or studying for finals. So yeah, the next 2 tests I'm going to give you are going to be take-home tests. All right, so here we have some properties. If the function is even, an even function, that means f of negative x equals f of x, then the integral from negative a to a can be rewritten as 2 times the integral of 0 to a, f of x dx. If it's odd, then this is automatically 0. So an example of this, let me see an example. All right. This is an even function. So the integral of negative 2 to 2 is f of x plus 6 plus 1 dx is equal to 2 times the integral of 0 to 2. Now again, it doesn't seem like that big a deal. Honestly, it's not that big a deal. But it is easier to plug in 0 than negative 2. Okay? So if you can put a 0 here, it's so much easier to do it that way. So yeah. This is a odd function. Now the nice part about this, if you know it's an odd function and it's going from negative 1 to 1 or negative a to a, it's automatically 0. I don't have to do anything. Now the reason why it's automatically 0, if you remember, we are adding areas, and okay, didn't mean to do that. On the very last slide. So yeah, if it's an even function, okay, that means that it mirrors across the y-axis, okay? So if I'm going from negative 2 to 2, this area is the same as that area. So I can just do 2 times this area and be done, okay? If it's an odd function, okay, this area and this area, this is a negative version of the area. Okay, so this is negative area and this is positive area, and they're equal, except one's negative, one's positive. So if I add these together, I get 0. That's why it's helpful to know if it's an even or odd function, especially if it's going from the same number, just different signs. All right, so I have the book open somewhere. At least I tried to have the book open. Let me see if I can find that. Let me pause this. All right, so I had the book up. Sorry, it took me a while to find it. My Adobe Reader, so I'm going to use some weird PDF thing I found online. So here, for 1, 2, and 3, this is on page 338 in your book. The questions 1, 2, 3, and 4, they actually tell you what to substitute for, but to be honest, it should be kind of obvious. You're always going to substitute in for the function that's inside another function, and parentheses is a key giveaway. Now, when I say parentheses is a key giveaway, you don't notice parentheses in every single one. However, I don't know what I write on there. There is parentheses here. Parentheses here. These count as parentheses, but these have parentheses. Even if they didn't, your denominator and numerator both count as parentheses. Okay? So, parentheses is a key kind of giveaway of what I want to substitute in for. So yeah, I'm going to move on because these seem pretty easy. They tell us what to substitute for. You're really going to start with number 7 here. Okay, so evaluate the indefinite integral. So you're going to have quite a few of these to do. Say quite a few. You're not going to have that many. because again, I just assume there's only 4 of you. A few of you will try it, and a few of you won't. So, and I can tell you, if you prove me wrong, I still win. So either I'm right or you do your homework. Either way, I win. That's how I am. Yes, please roll your eyes at that. All right. So number 8. Where number 8? No, I'm not gonna do that. Number 8 is the I'll just write it on here, see what happens. So number 8 is the integral of x squared of x cubed plus 5 to the 9 dx. Sweet, it stays on there. All right. So again, obviously I said parentheses is a key giveaway what I'm substituting for. So u is equal to x cubed plus 5. All right, and which means again, do the derivative, 1 du, and that's not a u, is equal to 3x squared dx because the 5 goes away. Again, if you notice, I have an x squared in dx, but I don't have a 3, so 1/3. 1/3. That is going to give you, let's see here, integral of 1/3 u to the 9th du, and the antiderivative of this, sorry, that the antiderivative of this, if we add 1, nope, not what I wanted, add 1, which means we're going to divide by 10. Instead of dividing by 10, we're going to multiply by 1/10. Gives you 1/30 u to the 10th plus c. Don't forget to add the constant. Now, again, we don't want this. We want to put this back in for it. So what we really get is 1/30 parentheses x cubed plus 5 to the 10th power plus c. And we're done. Again, really not that bad. Okay, it's a whole lot more complex. I can tell you, I can promise you this. The teacher I had who made us do this was terrible, okay? I do not know how he made something so simple, so complex. All right, so now there are going to be cases in which x doesn't disappear. Okay, notice how x squared disappears. There are going to be a couple instances where x doesn't automatically go away. And so let's see if I can find one. Let's see here. I think I saw one right here. This one right here, 28. Okay. So yeah, there's definitely going to be a case here where x doesn't automatically go away. So 28, I'll write it in yellow. So 28, I'll do it up here in the top corner. And what is that? Okay. So 28 is x squared, or we're doing an integral of x squared over the square root of 1 minus x dx. There it is. So here we want to say u is equal to 1 minus x, and then 1 du is equal to 1 dx. In fact, negative 1 dx. Isn't that nice? All right. Now, notice we don't have a negative 1 at all. So, multiply by negative 1. Negative 1 du is equal to 1 dx. So what this gives us is the integral of x squared over the square root of u du. This should be negative, okay? Actually, it doesn't matter where the negative is. So can put it up outside. That's fine right there. So now notice x squared didn't go away. So here's what we're going to have to do. When you have a variable that doesn't go away, you're going to take your substitution. U is equal to 1 minus x. And we're going to solve for x. So I'm going to subtract 1 over, subtract 1, and get negative 1 plus u is equal to negative x. So divide by negative 1 and get 1 minus u is equal to x. So what I'm going to do is I'm going to plug this in for x. Hey, more substitution, right? So we get the integral of negative 1 minus u squared over u to the 1/2. I'm just going to write it like that, du. And since I don't want to solve this, I can simplify this though. All right, 1 minus u squared, if you, again, FOIL it, so 1 minus u times 1 minus u. Okay, or since it's easier and faster and more efficient, and then what I'm going to do is just use the, what's it called? The Pascal's triangle, and how to square a binomial, which is to square the first term, multiply the two terms together and double it, and then square the last term. So we end up with the integral of negative 1 minus 2u plus u squared all over u to the 1/2. In this case, what I do is I rewrite this as negative 1 over u to the 1/2 minus 2 over u to the 1/2. So I basically divide each of these by u to the 1/2. And if you remember, when you divide by variables, you subtract their exponents. So this becomes the integral of negative u to the negative 1/2 minus 2u to the 1/2 plus u to the 3/2 du. Keep writing the du here. All right. Now we can distribute the negative, make it easier, so we get the integral of negative u to the 1/2 plus 2u to the, well, negative 1/2, 1/2 plus minus u to the 3/2 du. So we take the integral, the antiderivative of them separately. So we are going to whatever that color is. We're going to add 1, add 1, add 1, which is going to give me 1/2, 3/2, and 5/2. All right. Now again, when we divide by this, now this is what we're going to divide by, is basically multiplied by the reciprocal. So this is going to become negative 2u to the 1/2, 2/3, positive 4/3 u to the 3/2, and negative 2/5 u to the 5/2 plus c. So don't forget to add your constant, because this is an indefinite integral. And again, we don't want this. What we want is right here. Plug this in for u. I'm going to run out of room here, so we get negative 2, 1 minus x to the 1/2, plus 4/3, 1 minus x to the 3/2, minus 2/5, 1 minus x to the 5/2, plus c. And that is our final answer. All right, that was fun, wasn't it? Okay, you should all post, like, put a little comment on where you zoned out on. Okay, so where did I lose you? I wish we didn't have all this mess that was going on. I really do, because I really enjoyed coming into class. I can tell you my wife enjoyed having the kids in school, okay? So, oh my goodness, we love our kids, but it's just been so rainy and so wet, and they have been cooped up inside. Until today, we finally got outside today, and a little bit a couple days ago. Just not enough. They need to run, they need to exercise, they need to burn off the excess energy, because if they don't, they just aggravate everybody. Alright, hear this. I like how I'm still acting like I'm in class and you guys are nodding your head. Oh, okay. Alright. Let's do a trig function just because. I mean, it'll be fun. Okay. Oh, this will be interesting. Let's look at 24. Now, the reason why it's interesting is because it's written interesting. So, let's do this. I have to do this in a different color. So, that's a fun looking color. So 24, I don't know why it did that again. $24 was 1. I'm just doing 1, not dt. Okay, I'm gonna put dt off the side. Cosine squared t times the integral, or the that's the square root of 1 plus tangent t dt. All right. So now the reason why this is interesting is because, again, we're going to say u is equal to 1 plus tangent t. All right. And then du, 1 du is equal, that's going to cancel. The derivative tangent, if you remember, is secant squared t. Now, do you see a secant squared t? You don't, but you do. Okay, you do because this right here is secant squared t. All right, 1 over cosine t is secant squared t. So we could say, really, that this is the integral. Sorry, I forgot the integral symbol. The integral of secant squared t over the square root of 1 plus tangent t dt. Because if we just move it up, 1 over cosine squared is secant squared. So yeah, well, now we do have everything. This is dt. So we get rid of that. This becomes u. And we get the integral of 1 over the square root of u du. See, that's not too bad now that we simplified it. All right. So this is the integral of u to the negative 1/2 du. When we take the integral, we are going to that's a gross color. All right, so we're gonna add 1, which gives us 1/2, and we're gonna multiply by the reciprocal, so we get 2u to the 1/2 plus c. And then again, we just plug this back into u, so we get 1 plus tangent t to the 1/2 plus c. All right, so let's see here. Let's go back out and this. Let's go back out and let's look at some of these right here, because these are all going to be the same question, really. It's all going to be the same setup. So even the definite integration here, evaluate the definite integral. Okay. It's still going to be the same way. You're going to do the substitution. It's just you don't have to worry about c. You're going to have to do the antiderivative and then plug in the values for the antiderivative, just like we did in the PowerPoint. So I want to look at the questions at the end that talked about whether we have an even or odd function. Okay. So looking at this, evaluate number 53, given integral from -2 to 2. So it's good to decide if this is an even or odd function. All right. Now, first of all, we can prove it's an even or odd function by plugging in 1 and plugging in -1, or plugging in negative x, and see if we get the same function, but different signs. Okay, so here Actually, it's neither. That's awful. So, yeah, it's neither even or odd. This one here would be odd. Let's go down, because I don't think they actually... Let's see here. Oh, we didn't do those questions. They not have even or odd? I mean, they talked about it. I'm betting it's right here. Ah ha ha, there it is. Is that the only ones they give you? Okay. Alright, we'll deal with it. 42, if this is an even or odd function. It's a I think it's an odd function, because I think sine is odd. No, let's see, sine set to 0. Nope, sine is a yeah, sine is odd. Okay. But that's even and that's even. So if I plug in negative x, I'm going to get negative of this function. So yeah, it's an odd, which means your answer is 0. And that's kind of nice. It means you're done. Your answer is 0. Okay. So number 42, odd function, answer 0. All right, so that's gonna be it for tonight. I'm getting kind of tired, so if you have any questions on homework, I'll just tell you what it is. I'm just gonna have you guys do like every other odd. So we're gonna start with let's say we start with number 7 here. So let me write this down as I say it. I'll put this up on Google Classroom. Okay. Oh, nice. I have no internet. So, alright. Anyway, I'll stop recording and I'll just post the homework, and I'm going to have to figure out what I'm doing about, internet access. Because I'm guessing our internet thing downstairs stopped working again. So, our router or modem or whatever it is. So, that's always fun. Anyway, I'm going to just tell you what it is. It's going to be 7, 11, 15, 19, 23, 27. And then I'm going to do, let's get these, 35, 39. We'll do 41. So we'll do 37, 41, 45. Okay, that'll be good enough. All right. I will post it as soon as I can.